220V tin Ka surge protection solution. Power surge definition and sources. A power surge is a transient overvoltage phenomenon that exceeds the normal operating voltage of equipment. External sources of power surges: lightning and grid switching operations. Lightning is a natural phenomenon that may affect electrical systems. Grid switching operations are human operations and may cause changes in current and voltage in the power system. Internal sources of power surges: inductive and capacitive loads. Inductive loads such as air conditioners, elevators, and welding machines may cause changes in current and voltage in the power system. Capacitive loads may produce capacitive effects and affect the power system. Transient overvoltage refers to a sudden increase or decrease in voltage in a power system. This change in voltage may last for a short period of time but may cause damage to electrical equipment. Transient overvoltage may cause damage to equipment with weak insulation properties in the power system, such as capacitors, transformers, etc. Lightning is one of the common external disturbances in power systems. The lightning current and lightning electromagnetic field it generates may have an impact on the power system. To protect electrical systems from lightning, lightning rods or arresters are often installed on wires. Grid switching operations are another common external disturbance. This operation may cause changes in current and voltage in the power system. In order to reduce this impact, some measures are usually adopted, such as increasing the flexibility of switching operations, reducing operation time, etc. Inductive loads are one of the common internal disturbances in power systems. Such loads include equipment such as air conditioners, elevators, and welding machines. They produce certain inductance and resistance when working, which may cause changes in current and voltage in the power system. In order to reduce the impact of inductive loads on the power system, some measures are usually taken, such as increasing filter capacitance and improving the power factor of the equipment. Power surges can cause damage to equipment in the power system and shorten the service life of the equipment. Additionally, it may have an impact on running electronic equipment, leading to data loss or equipment failure. In the United States, direct losses caused by power surges to various industries are as high as $26 billion per year. These losses include equipment damage, data loss, and production interruption. In China, there are also a large number of electrical products that have problems caused by power surges during the warranty period. Direct losses caused by power surges are as high as $26 billion every year, involving equipment damage, data loss, and production interruption. Power surges may cause damage to transformers, circuit breakers, motors, and other equipment, seriously affecting production. Power surges may cause failures in computers, servers, and other equipment, leading to the loss of critical data and affecting business operations. Power surges may interrupt production lines, affect product quality and quantity, and damage corporate reputation and market competitiveness. In China, a large number of electrical products have experienced problems due to power surges during the warranty period, including equipment damage, data loss, and production interruption. Statistics show that 63% of electrical product problems are caused by power surges, indicating its huge impact on electrical equipment. In order to prevent damage to electrical equipment, it is necessary to strengthen the insulation performance of the equipment, install surge protection devices, and train users to improve their self-protection awareness and skill levels. By installing surge protection devices, the energy of power surges can be effectively absorbed and dispersed, and damage to electrical products caused by power surges can be avoided or reduced. Surge protection devices can protect the normal operation of equipment and avoid equipment failure or shutdown caused by power surges. By reducing the damage caused by power surges to electrical products, the service life of equipment can be extended and economic losses caused by equipment damage or shutdown can be reduced. Installing surge protection devices in electrical products can effectively absorb and disperse the energy of power surges and avoid or reduce damage to electrical products caused by power surges. According to the actual situation of electrical products, select appropriate protection devices, such as MOV, GDT, etc., to ensure the effectiveness of surge protection devices. According to the characteristics of power surge, The parameters of the protection device are adjusted so that it can effectively protect electrical products under different surge conditions. Adding a protection layer after the common mode coil can further reduce the residual voltage and improve the safety of the equipment. When selecting equipment, its residual pressure characteristics should be considered and equipment with lower residual pressure should be selected. If increasing the protection level and optimizing equipment selection still cannot solve the problem of excessive residual voltage, the protection scheme needs to be adjusted and other protection measures should be considered, such as using nonlinear resistors and adding filter capacitors. To add a level of protection after the common mode coil, appropriate protection equipment needs to be selected, including MOV, GDT, etc. These devices need to be able to withstand expected overvoltages and overcurrents without causing additional obstruction or disruption to the system. After selecting a protective device, its parameters need to be determined, including voltage capacity, current capacity, response time, etc. These parameters need to be selected based on the actual conditions of the system to ensure that the protection device can provide effective protection when needed. When adding levels of protection, the layout and installation of the equipment also need to be considered. These devices should be as close as possible to the equipment being protected, and other components or loads in the line should be minimized to avoid adverse effects on the protection effect. Consider its voltage capacity and current capacity to avoid premature breakdown caused by too small voltage capacity and avoid overheating damage caused by too small current capacity. Select according to the actual situation of the system. Consider its discharge current and extinguishing voltage to avoid premature triggering due to too small discharge current and failure to extinguish timely due to too high extinguishing voltage.
Open Circuit Voltage Waveform 1, 2, 50 ms, 1, 2 ms, 250 ms.
Short circuit current waveform 8/20 microsecond T1 equals 8 mus T2 equals 20 mus. If during the test, the residual voltage of the surge is too high, causing damage to the equipment under test, you can add a level of protection behind the common mode coil within the red dotted line. The selection of the device can be the same as the previous level, or you can choose slightly smaller pressure-sensitive and gas discharge tubes are used to save costs.